Good morning and welcome to Bear Creek Elementary in Katy. We have some special 3rd and 4th graders that I'd like to introduce you to. Here are my 3rd graders. Can you guys say hello? Oh man, that was a great introduction. Come on over here, Roger. Here are my 4th graders. Okay, I tell you what, Roger, I think the 4th graders won on that because my ears are ringing, but you guys did a great job. My name is Anthony Yanis. I'm a meteorologist over at KPRC2, and I'm going to talk to you guys about 2 things today. First of all, we have a total solar eclipse coming up in 40 days in the state of Texas. And then we're also going to talk about, of course, the solar eclipse, solar meaning sun, and then we're going to talk a little bit about the sun, how it makes or it helps create our weather. So let's start with, first of all, the total solar eclipse. This is when the moon completely covers the sun. So I think you guys have probably seen this in your classrooms where you have a sun, you have a moon, actually you have the earth and you have a moon. So we all know that the earth revolves around the sun. How many days does it take to do this? Excellent. It takes 1 year, 365 days to make that trip. I can make it with my hand in a matter of seconds. And we also know that the moon travels around the earth, and so there are times that the moon passes into the sun's shadow and we get the sun completely blocked. So this is happening at the same time that the earth is traveling around the sun. And it's going through the state of Texas. In Houston, if you are here in 40 days, which you will be unless your parents take you out of school, in 40 days, we in Houston, in Katy, are going to have the sun covered by 94%. 94% of the sun's disk is going to be covered. But how does this happen? During a solar eclipse, the moon blocks out the sun. First of all, it's actually pretty incredible that this happens at all for a couple of reasons, and I need some people to help me show an example. Come on up. Yes, you. And then you, too. Yeah, we're going to start with 4th graders, then we'll do 3rd graders. I need you to hold up the earth, okay? You are going to be the moon. So, oops, go ahead and hold that part. What's your name?
Ivan.
This is Ivan. Everybody say hi to Ivan. Okay, and then who is this? This is?
Emily.
Emily. Everyone say hi to Emily. Hi. So first of all, what I want to do is, Emily, I want you, I'm going to have you walk away. What I'm going to have Emily do is I'm going to have you hold that, and you are going to walk away. We're going to first of all show how far away the moon is from the earth. Go ahead and walk. Keep walking, and make sure you don't, be careful not to step into the cameras. Walk this straight line. Go to the right. Go to the right. Oops. Keep walking. It's okay. Go to a little bit to the right. Now go back. Go back. I just want to make sure you don't hit the tripod. Keep walking. You got to walk all the way back. Keep going. You got to be quicker. But be careful because of the tripod so you don't hit that. Keep going. Keep going. Keep going. Take some big steps back. Keep going. Okay, good. Now you can go. Keep going. So what we're showing here, the distance of the moon, look how close the moon looks to the earth in that image that I have up there. Keep going. Keep walking. In reality, stop. In reality, come a little closer to me. In reality, this is how far away the moon is from the earth. It is 9.5 diameters of the earth away from the earth. How far away is it? No, you tell me, are you far away or are you close?
Far away.
Far away. Now, for this image to actually be even more accurate, the sun would need to be a half a mile over there. That's how far away it is. You guys, good job. Come on up. Let's put our demonstrations back. So I have a question for you. I was just showing you how this works. Why don't we get a solar eclipse every month? If the moon travels, you guys, big round of applause. If the moon travels around the earth every 27 and a half days, why do we not get a total solar eclipse somewhere on the earth once a month? Did you know that the moon is actually tilted at 5 degrees? So when it travels around the Earth, it doesn't travel in a straight line. It travels at a 5-degree tilt. If it traveled in a straight path, we would get one every month. But because of that 5-degree tilt, many times it's just passing through and we see it, or it might be a partial eclipse. But it's that 5-degree tilt that makes total solar eclipses so rare. In fact, the last time Texas, the state of Texas, saw a total solar eclipse was in 1878, when I was only 2 years old. The next eclipse that is going to travel through the United States of America is in the year 2045. The odds of us and Katy getting a total solar eclipse where we don't need to leave, where our parents don't need to take us out of school, is once every 375 years. So that 5-degree tilt and that distance that you saw from the Earth to the Moon makes total solar eclipses incredibly rare. Also, on a normal day, we don't look at the sun. I guarantee none of you guys walking to school, taking your bike to school, getting a ride to school, looked up at the sun. First of all, it's cloudy, but it's not something we do on a regular basis. But when there's a partial eclipse or a total solar eclipse, it is something that we want to do. But I just want to let you know that in 40 days, don't look at the sun. First of all, it's going to hurt. So your body's going to tell you automatically, I shouldn't be doing this, unless you have a way to look at this. Sunlight damages your eyes. A safe way to see an eclipse is solar eclipse glasses. Okay, let's get our third grader here for an example. Come on up. Let's see. Yes, right here. Come on up. What's your name?
London.
London? Oh my gosh, I love your shirt and I love your name. So London is going to put on a pair of solar eclipse glasses. London, I want you just to cover your eyes and I want you to describe to everybody what you see. What do you see?
Dark.
You see dots.
Well,
it might be a little. Oh, it's dark. She's saying it's dark. So you know you have good solar eclipse glasses when it is completely black. Let me give London another example here. So London, are these good solar eclipse glasses? Put them on and look at the light.
It's shiny.
It's shiny.
And it's light.
Yes, shiny and light. These are not solar eclipse glasses. These are bad. Anytime you can see light, they're bad. Sunglasses are bad. Anything except for solar eclipse glasses are not good for you to view the solar eclipse. Good job, London. London, good job. So if you're going to look at the sun on April 8th, you've got to have solar eclipse glasses. And these, by the way, are from KPRC too. Great question. How do you get some? So your parents need to get some, and then I can give that one away to somebody also. Another way you could do this is you can make there's actually a bunch of different ways, but you can make a pinhole camera. So you're not actually looking at the sun, but you could do who likes Cinnamon Toast Crunch here? I love myself some Cinnamon Toast Crunch. But all you do is you cut out the top, you put a white sheet on the bottom, and there's actually ways you can do this, and there's more that your teachers will do. You put one little pinhole, pop. You just need a tiny hole from like a safety pin. The sun is behind me. If I put the sun right here behind me and I look at this, I'll actually be able to see the partial solar eclipse. And you're never looking at the sun. And you get 94% of the sun covered. So it's actually really cool what you get to see. So here's what you need to know. The total eclipse times in Houston, Monday, April 8th, at 12:20. So this is lunchtime for you guys, or maybe after lunch, is when the partial eclipse starts. 1:40 in the afternoon is when 94% of the sun is covered. At 3:01 in the afternoon, when do you guys get out of school? What time does your school bell ring? 3:15. So at 3:15, the sun's back to normal. 94% of the sun surface is covered here in Katy. But if you travel up to the north, you get totality, which is pretty incredible. Okay, moving on. So I just wanted to give a little bit, I talk a little bit about the solar eclipse. So I tried that out. It wasn't as much of a disaster as I thought it could have been. So let's talk about the sun now. The sun is 100 times bigger than the Earth. So what you have in your textbook and what you have here are models, because you can't show this as 100 times bigger than this. Otherwise, if this was accurate, it would be the size of an O on your computer. That's how small, that's how big 100 times bigger is, but you can't really model that. The sun is 93 million miles away from us. It takes 8 minutes and 20 seconds for the light from the sun to reach us, which means we're always walking around in old light. If you go outside on a sunny day and the sun is hitting you and you're like, ah, this is warm, that sunshine that's hitting you is 8 minutes and 20 seconds old. When you see a beautiful sunset and it goes down, the sun is actually set for 8 minutes and 20 seconds. It's already been gone, but that's how long it takes the light to travel to us from Earth. The sun also plays a big role in getting rain. So convection, and this is a good example of what may happen tomorrow, at least for rain, not lightning. But the sun heats the Earth, the air heats up and rises, clouds condense, and rain, or sometimes storms can form. So this is heat created through liquid and gases. So now I need someone else to help me with this. Let's do a third and a fourth grader. I need strong third and fourth graders. So let's find, okay, right here, Pink, come on up. And let's do a boy here. Okay, yes, come on up. Is that Puma? Okay, come on up. Okay. First of all, what's your name?
My name's Carol.
Carol, go ahead and turn around so everyone can see you. What's your name?
CJ.
CJ. We got CJ and Carol here, okay? So, first of all, what I'm going to do is we're going to talk about, why don't you hold that for me, Carol? We're going to talk about 2 water drops, all right? So, everyone saw I put 2 water drops in my hand, right? If I go like this with my hand's getting hotter. Those 2 water drops, I didn't kill them. What happened to the water drops?
They dried up.
They dried up, but another word for drying up is? They evaporated. Good job, good job. They evaporated. So they're still around here, but they're not water drops anymore. So we're going to talk about convection now and condensation. So we're going to put in a couple more water drops here, and then I'm going to shut the lid. So first of all, can you see what the temperature is? Let's see. Can you see? Can you see what it's in Celsius?
26.
Is it really 26 right now? It's warm in here if it's 26. That's fine if it is. You see? What do you think the temperature is? Can you see that? It is kind of difficult to see because it's dark.
26.
26. It is 26. Okay, so we need your muscles. Ready? What you're going to do is you're just going to pump this up. Okay, got to hold it. Okay. Good. Go ahead and take a break. Okay, finish it out. Keep going until it's really, really hard to do. Got it? Good job. Do you get everything? And try a couple more. Now tell me what the temperature is. Can you see it? Can't. How about if I turn it around? See, it's hard. It is hard. Yeah, it's okay. There about now.
28.
28. So it did warm up a little bit in here. It got hotter inside here from 26 degrees Celsius to 28. So we're going to see what happens here. So remember, think of this as the sun. Oh yeah, you guys did a great job. The sun is heating the earth, and then what you get is a lifting from the ground to the top. So what should happen to the 4 water drops that I put in here? They're going to evaporate. Okay. So when I did this, I made them evaporate. What do you think happens to these? You think they're going to evaporate? What do you think happens?
I think they're going to spread around the bottle.
They're going to spread around the bottle. If they spread around the bottle, what will it look like? A cloud. So it's quick, but we just created a cloud. So that's what's happening there. And it's all because the sun does that. It lifts the moisture on the ground. It's invisible, just like what I did, but it'll condense. It creates clouds. And eventually, if we could make this and make this a bigger demonstration, it would create rain. Good job, you guys. You did great on this. So high and low pressure is important for storms because you need low pressure, which is what we're going to have tomorrow, which is going to make a little bit of light rain. High pressure is really tough to create rain in. But first of all, with wind, wind flows from high to low pressure. So if I'm high pressure and you're low pressure, wind goes from me to you. So it's moving towards you. So here is wind going from me to you. It doesn't hurt, but that's the way high pressure moves, or wind moves, from high to low pressure. Now, I need a couple more people to help me with this. I need, let's do the back this time. How about right there in blue? Yes, come on up. And then in the back, yeah, right there. Come on back. Yep. So first of all, air pressure is the weight of a column of air above the surface. Come on up. High pressure is heavy. We don't feel it, but high pressure is heavy. Come on up here. Low pressure is light. High pressure is heavy, low pressure is light. If there's low pressure, the clouds build up and it rains. If there's high pressure, it's really tough for clouds to build up and to get rain. So what I'm going to do is I'm going to create high pressure. What's your name?
Sergio.
Sergio. Okay, Sergio, I want you to take 2 fingers and lift this straight up. Straight up. Don't go at an angle. Straight up. Okay, Sergio. Okay. Okay, stop, Sergio. What's your name?
Emmy.
Emmy? Oh, that's a pretty name. Okay, Emmy, 2 fingers. Try to lift it straight up. Okay, Emmy, describe what's happening.
Can't lift it.
You can't lift it? Okay, wait. But this is easy, guys. This right? It's light. What's happening? Why can't Emmy lift this? Try it again. No, try it again. You can try it. Try it again. Ah! Try it again, Sergio.
Because of the pressure.
The pressure. So what we've done is we have created pressure. So there's low pressure here. We have locked in the pressure, and now we can't lift it. That's how heavy high pressure is. So it's tough to get rain when it's high pressure. When it's low pressure, it's really easy. So good job, guys. Give them a big round of applause. So here's how I forecast the weather. We were talking a lot about the sun today, but the sun will create storms like we were seeing with the condensation, with the convection. Radar shows me where that hook echo would be a potential tornado. And we have recording stations, so I know what the temperature is in Katy right now. I know what the winds are, what the wind gusts, and the humidity is. I have surface maps. So do you see where the H is, the high pressure on that map to the left? Do you see how it's all completely clear? There's no clouds there. It's heavy. It's stopping even the clouds from forming. Where the low pressure is up to the north. And where low pressure is usually, there's going to be storms. And I also look outside. Today was an important day to look outside because the little sprinkles that we had on the way out here to Katy, the clouds were so low, guess what? I didn't see them. I couldn't see them on the radar. But if I would have gone outside, I would have said, yeah, look, it's kind of sprinkling a little bit. Not very heavy, but it's sprinkling. Did we drive through a little sprinkle today? We did. So if the rock is wet, it's raining. If the rock is swaying, it's windy. If the rock is hot, it's sunny. If the rock is cool, it's overcast. If the rock is white, it's snowing. If the rock is blue, it's cold. If the rock is gone, tornado. And then I make the graphics. So then I tell, what is the message for the weather today? Is it going to be dry? Is it going to be hot? Is it going to be wet? Is it going to be severe weather? Are we going to get flooding? Do we have a potential for tornadoes? And then I tell you, the one interesting thing about this bottom image here is if I'm ever in front of a green screen and if I go home and I brush my teeth, the toothbrush is over here. If I brush my teeth on television, the toothbrush is over here. So the hardest part of my job when I first start is seeing myself in reverse. So it's your turn. You're going to do the weather for your school and city, give the current temperatures, what's our weather today, and what happens tomorrow. Could I please get up Jackson, Tabitha, and Daniel to come on up here? We are going to do the weather. Here's what's cool about this. There is a delay. They're going to see themselves live. I'm going to switch over and show you how they do. You ready? Come on out. Let me get to the correct map. Let's get you in place, and Roger's going to set you up. And once he is set on his tripod, we are good to go. Okay, you remember what to do? Okay, I'm gonna leave you, and I'm going to set up so everybody can watch you. Ready? Take it away.
Hello everyone, I'm Jackson from Bear Creek Elementary, and today I will be telling you the weather. Today it is windy and 62 degrees. The humidity is 59% and the wind is southwest. The wind gusts are 17. So there is a cold front coming from the north going to Galveston, And so if you're in Galveston, you better get ready for a cold front. It'll be windy through all of Houston. Yep.
Press the middle button. Okay.
On Wednesday, tomorrow, it'll be in its... Wednesday's today. It'll be in the 60s. And tomorrow it'll be 58. And slow percent is 48. On Friday, it'll be 72 degrees, going to 84. 48, my bad. 48.
Say goodbye.
Goodbye. And subscribe to my YouTube channel, Jackson Storms ASMR.
Yay! Good job! Good job! All right, Tabitha, you ready? Okay, Tabitha, you are all set. Remember to introduce yourself, and I'm going to get out of the way. Okay, now you, Daniel, you can sit here and watch yourself. Go ahead and watch yourself.
Hi, my name is Tabitha.
Oh, Jackson. Sorry, Jackson.
I'm reporting from Bear Creek Elementary. Today, the humidity is 59%. The wind, the high is 62 degrees. Wind gust is 17 miles per hour. There's a wind gust coming through Houston. Wind today, it's in the 60s. Thursday, it's going to be 58 is the high and 48 is the low. And 72 on Friday is 77 is the high on Friday, and 48 is the low on Friday. And bye.
Good job. Good job. Excellent job, Tabitha. Way to go. All righty, Daniel, you ready for this?
Yes.
Okay, Daniel's ready for this. Okay, I'm out of the way.
Wait, where do I stand?
You're in the perfect place.
Oh, it is live.
Yep.
Hello, my name is Daniel Sanchez, and today I'm presenting the weather. So, right now at Bear Creek Elementary, it's 62 degrees. It's not that bad, but still, it's pretty cold. The weather right now in Katy is 62, like I just said. And the low is 54 at College Station, and the high is 73 at Angleton, I think. Yeah, Angleton. These are the wind gusts. I don't know what this means, but it's pretty important, I'm sure. So, yeah, that's the weather. Bye.
Good job. Good job, Daniel. Come on over here. Okay, you wanna watch yourself? Okay, let's watch yourself. Hey, you guys, no, Daniel, stay with me. Daniel, come back here. Daniel, come on. How much time do we have left? 2 minutes. Okay, you guys remember, after I interview Daniel, Daniel, come up here with me, right here. we're going to say a big goodbye to everybody, okay, who's watching. Okay, Daniel, come on. I want to interview you. Okay, so first of all, we're watching you right now. There's a little delay. How do you look?
Great, I guess.
You look great, you guys. You did great. You know what I love is because you used your personality and you looked at the wind gust map and you were like, I guess this is important. I don't know why, but I guess it's important. That's like great to be able to show your personality like that. That's so fun.
I actually don't know.
Yeah, well, you know what? You are in the 3rd or 4th grade?
3rd.
You're in 3rd grade? Yeah, so you'll learn about this later in life.
Oh.
But good, you look great up there. I love your shirt. You're representing your school. Doing excellent. Way to go. Everybody give all 3 of our presenters. Jackson, good job. Where's Tabitha? Where's Tabitha? I lost Tabitha. We have 1 minute left. Okay, are you guys ready to say goodbye? Yeah! Can all my 3rd graders say goodbye? Can all my 4th graders say goodbye?